All right, so let's look at the homework converting between logs and exponential form. So, number one, we want to write each equation in exponential form. Meaning, so we'll write the little cheat sheet rule. So if I have log base whatever this is equals, I can go between the base raised to the exponent, and this will equal whatever the argument is. Remember, it's the base raised and then equals. Raised and then equals. You can't even read that. All right. So 3 raised to 2 equals 9. 3 raised to 2 equals 9. And that makes sense, right? That's 3 squared is equal to 9. We already know that. So raised, and then up here is equals. All right, these go very quick when you're nice. So 3 raised to this equals 1/5. Or 5 raised to -1 equals 1/5. 5 -1 equals 1/5. And that makes sense because the negative exponent will move that base down into the denominator of a fraction. And that's correct. Okay, 3. 2 to the 0 power, anything to the 0 power is equal to 1. So 2 to the 0 power is equal to 1. This homework's going to go quick, I can already tell you. So do we still need the little cheat sheet, I wonder? And let's see. Can I select it? Okay. Well, I tried. All right, so 3 raised to 1 equals 3. Right? Anything raised to the first power is itself. 8 raised to 2 equals 64. 8 squared is equal to 64. 10 raised to 2 equals 100. e raised to 3, e cubed is approximately this. Right? It's approximately because e is a rational number like pi. It goes on forever. So e cubed is approximately 20.085. Okay. Write each equation in logarithmic form. Again, we fall back on this rule here. So the base, that's the little b, the exponent will be the part that is equal to, and the square is the argument. So here, look, I'll put one here. Okay. So working backwards, I know it's going to be a log because I want it in log form. So the base, base 5, the square, and this equals what? The triangle, the exponent. And that makes sense. 5 cubed equals 125. So if you like kind of like check yourself real quick, that's correct. All right, see if we can go quick without making any mistakes. That's the goal, right? So log base 5, 125 equals -2. 5 to the -2 power equals this. Yep. Yeah. Anything to the 0 power is 1. But let's stick to the script, right? Stick to the script. So this is going to be log base e. We'll talk about this later. One equals 0. That's a property, right? Log base anything to the 1 argument is 0. That's a what was it called? A property. Okay. Do we still need the guide? I feel like we're good. We don't need it. So log the base is 1/4. $64. And the exponent is -3. All right, 1/4 raised to that equals that. And that's exactly what it would be. What it is. Okay. We don't need that anymore, I feel. Log. All right. Base 10. I'm not going to write the 10. It's kind of irrelevant to write the 10. Or should I write it so you can see it? Log base 10. 10,000 equals 4. So normally you don't put the 10. I know I keep saying that, I keep writing it because I guess we're still learning. But on this next one, I definitely ain't putting the 10. So log, no base, it's implied that it's 10. (1/10) equals -1. Right, when you don't put anything, it's implied that there's a 10 there. Log base 9, 27 equals 3/2. Log base 4, 1/8 equals -3/2. Right, it's not necessary to put the arrows. You just do that to check yourself, but I know that we're good. So okay, determine the value of each logarithm without using a calculator. So no calculator needed. What you want to do is set this equal to something, right? In all of these, there's no equal sign. So you have to set it equal to something. You can use whatever variable you want. I like using x just because that's typically what we use in algebra. So I set equal to x. So then you convert it to exponential, and then the x typically becomes obvious. 2 to the x power equals 2. So 2 to the x power equals 2. All right, so think about this. With 2, it's implied that the power is a 1. All right, so 2 to the x is equal to 2 to whatever the exponent is. So because the bases match, we can equate the exponents to each other. So x is equal to 1. Right, we're not solving for x, right? Because the problem didn't give us x. We created this variable x. So the answer is just 1. Right, that's the value of this log. Right, log 2 is equal to 1. Log base 2 is equal to 1. And again, there's a property, right? It's a very important property that if the argument and the base equal each other, right? Log base whatever, and the argument is equal to the base, then this is going to equal 1 every time. Every time. When the base and the argument match. So again, look, the base and the argument match. Do we even need to go through all of this? I don't think so. It's 1. Right, the answer is 1. When the base and the argument match. Right, you can't have anything else. The base and argument have to match. Okay, 19. Set it equal to something. 12 raised to something equals 144. So there's a couple ways of thinking about this. If you apply the method that we just did, you could turn 144 into base 12, right? As in 12 squared. Then the bases match, so we can equate the exponents. But really, if you just look at 144 and you know, oh, that's 12 squared, x has to be 2, right? Logically. But if, let's say you're just learning your times tables. So in fact, it's not x equals 2. It's just 2. The answer is 2. Okay. Number 20. Set it equal to something. 10 to some power is equal to 100. So 10 to what power equals 100? It's got to be squared. X equals 2. So it's not necessarily a property, but it definitely is a pattern. So if the argument is the square of the base, right? And this is just pattern recognition. Will this happen all the time? Like, no. But when it comes up and you can recognize it, it makes it nice. When the base is, or the base squared equals the argument, then the answer is 2, right? Just like in 19. 144 is 12 squared. So there's definitely a pattern here that you can pick up on. Okay. Log e base e. The base matches the argument is equal to 1. And what are they doing? Why are they so easy? Okay. I mean, take it when you can get it, right? Okay. Look, what did we just say? When the argument is the square of the base, and the answer is 2. And there's a property I want to show you really bad right now, but I think it's going to come up in another video. I'll do it in the next video. Or a separate video. But here, just in case you missed it, e to the x is equal to e squared. Then you can set the exponents equal to each other. This is going to equal 2. Okay. This one's a good one. All right, it almost looks like what we've been doing, but now the base is the argument squared. So this is going to be 9 raised to something equals 3. So if the argument is the base squared and the answer is 2, when it reverses, when the base is the argument squared, it's going to be 1/2. But let's just say you don't see that, because that's fine. Right? I know that the square root of 9 is 3. Right? The square root of 9 is 3. So the exponent is going to be 1/2. But I mean, is there more to it? Maybe there'll be some more examples where it shows this, right? But here, notice the base and then the argument. When the argument is squared, or when the argument is the base squared, the answer is 2. Here, it looks very similar, but the base is what's squared. Right? The base is the argument squared. And so it's 1/2. Okay. I mean, you got to look at it enough to eventually see it. So can you see this? Look, this is, so here's the argument, which is 7. And then the base is the argument squared, right? This is going to equal 1/2. For the same exact reason for 23, right? 49 to something equals 7. Well, it'd be 1/2 because 1/2 is a square root. And so the square root of 49 is 7. We're almost done. Let's go. Okay. There's no trick on this one. Technically there is, but let's just work it out. So again, 6 raised to this equals this. So 6 to some power is equal to 1/36. What's this one? I know it's going to be negative because there's a fraction, but you could say 36 or x to the 6 to the x power, 36 to the -1. And then, right, because that brings the 36 up. And then we could rewrite 6. We could rewrite 36 as base 6 squared. Right, because if you think backwards for just a moment, 6 squared is 36. So this means, right, when you have a power raised to a power, you multiply -2. So now that we have the same base that match, and only one exponent, we can equate, set them equal to each other, the exponents. So this is going to equal -2. And that makes sense. Mainly because 6 to the -2 power would be 1/36. That's exactly what we've got. So can we look at 26 and see what that answer would be just from applying what we just learned in 25? Right, the base is going to be this number squared, or the square of this number, 36, right? 6 squared is 36. So here, for the exact same reason, 5 and 5 squared is 25. So this is going to be -2 as well, for the exact same reason. Except wherever there's a 6, you put 5. Where there's a 36, you put 25. For the exact same reason. Right, this is the heart of a mathematician right here. If I have a problem that looks like another problem that I know the answer to, then I can solve it quickly. All right. You could apply the same property here, but let's just work it out. So e to the x, so e to something, is equal to whatever this is. I'm going to go ahead and just rewrite it as -3. And then x is equal to -3. Therefore, this is equal to -3. So notice that 3, the power, that's basically our answer. Right, especially back here, you could rewrite this as 5 squared. And then our answer was 2, but because it was in the denominator, it's -2. Right, that's exactly what's happening here. The answer is 3 because it's the power, but because it's in the denominator, it's -3. So with that being said, what's the answer to 28? This is really e to the 1/2 power, because that's what a square root is, right? It's 1/2 power. But because it's in the denominator, it's going to be negative. The answer, that is negative 1/2. Right? It's 1/2 because that's the power. And then it's negative because it's in the denominator. Man, all these are like that. That's kind of awesome. So look, again, same idea. What's the power? The power is 1. It's implied that it's a 1 there because there's nothing there. It's understood. Everyone knows that there's a 1 there. So my answer is going to be a 1 for sure. But because it's in the denominator, it's negative. Man, there's like, I'm about to say there's a property that would really come in handy, but I'll show that video later. Let's just stick with this, right? This is good. All right, last problem. What are we at? 26 minutes? Okay. So cubed root of e. This can be rewritten as e to the 1/3. And literally applying the last two problems, right? The answer is going to be 1/3, but negative because it's in the denominator. Okay, there it is. Good luck.